let's do this. So today we are covering joins. So a join in MySQL is used to combine rows from two or more tables based on a related keyword between them, usually a common field or a primary key or a key relationship. We have quite a few types of joins. So MySQL supports several types of joins to cover different needs when combining data from multiple tables. Each type of join serves a specific purpose depending on whether or not we want to include unmatched rows from the tables being joined. A little bit of a breakdown on the main types of joins you can see in MySQL. This includes left join, right join, inner join, and how to simulate a full outer join using a union. So an inner join returns records that have matching values in both tables. It essentially selects rows where there's a match or the condition in both tables being joined. We use an inner join when we only want to see data that is presented in both tables. This is the most common type of join when the relationship between the tables should be mandatory. The left join or the left outer join. A left join returns all records from the table, so table 1, and the matched records from the right table, so table 2. If there's no match, the result is null, or columns from the right table. This is useful when you want to focus on all records from the left table regardless of whether or not they have matches in the right table. So we use the left join when we want to keep all the data from the left table, even if there's no matching data in the right table. It's often used when you care about records from one particular table and need supplementary data from the other table if it's available. The right join or the right outer join. It returns all records from the right table, so table 2, and matched records from the left table, table 1. There's no match in table 1, it's null. It's essentially the opposite of the left join, where we ensure all records from the table appear in the result set regardless of whether there's a match in the left table. So when we want to focus on retrieving all records from the right table, even if the rows in the left table do not match, we'll use this join. Simulating a full outer join or a full outer join. So unlike inner join, left join, right join, a full outer join ensures we combine all the records from both tables. Rows from both tables are included even if they don't have a match in the other table. If a row doesn't find a match in the other table, the missing side will be filled with a null. So MySQL doesn't actually support a full outer join directly, so we end up simulating it by combining the results of the left and right join. We do that using a union. So when you want to see all the data from both tables, including rows that don't have corresponding matches in the other table, that's when we would use this. There's also a cross join, which returns the Cartesian product of both tables, meaning every row in the first table is paired with every row in the second table. You gotta be careful because this can produce large result sets, especially when both tables contain massive amounts of data. So we use the cross join when you want to combine all possible combinations between two tables. It should be used with caution because the results will grow significantly if the tables have a large number of rows. There's also a self-join, which is when a table is joined with itself. It effectively is comparing rows within the same table. MySQL allows you to treat a single table as two tables by giving it an alias. So we use self-join when you need to compare rows within the same table. For instance, this might be applied to find relationships between rows in hierarchical data. We use joins because data from multiple tables might be required. Joins allow you to retrieve related data from multiple tables, often based on a primary key and a foreign key relationship. We want to combine related records, so by using joins, you can combine records from different tables into a cohesive result set that includes all necessary information, whether you're looking at relationships between tables or combining multiple points of data. Joins provide a way to query large sets of data in organized and computationally efficient ways, allowing you to craft queries that specifically target related records across multiple tables. So in order for us to do this, we need to first, I need to delete the Minecraft database, and then we need to create the Minecraft database. So I'm just gonna refresh just to make sure it's not there. Next thing we do is we're going to execute. We're gonna create a first table. Then we're gonna create our second table. Then we'll create our inventories, our blocks, layer blocks. Now we need to add our data. Now we're going to go through some of our select statements, just to make sure everything is working the way we want it to work. Oops, that was our joins. My bad. What disaster. So this is our first join, which is an inner join, and it shows the items each player has in their inventory. As you can see, only positive results come out. Next thing we do is we're going to do a left join, so our left table, or table 1, is full. Our right table, still, it's missing some data for Herobrine. In our right join, same thing, so our blocks here still produce results even if there's a null value. This is going to be our simulated outer join. We're going to do a left and then a right join. And as you can see, we get our outer join done. Really, really simple overall, once you practice it a few times.